Hi, my name is Emily Huynh. Today I'm going to talk about HBase. I will go over what HBase is about, its key features and benefits, when to use HBase, and quickly touch on the HBase shell commands. Second part of the presentation, I will share with you my small proof of concept that I worked on, disregarding a data conversion for a small relational database. HBase is an open source, one of the Apache projects initiated out of the need to process massive data. It has gained lots of interest in recent years and is now one of the top-level Apache projects. HBase is a type of NoSQL database. It's a column-oriented distributed database management system. With this type, table name and column families are required during table creation, but the columns belong to column family can be added on the fly during data insertion as needed. It's written in Java, much like typical MapReduce application. HBase runs on master node in region servers. Master node manages the cluster, and region servers store portion of the tables and perform the work on the data. HBase lacks many of the features you find in relational database management system. It does not support query language like SQL. It does not optimize for transactional application or support cross-record transactions. Does not support joins, tie column, secondary indexes, and triggers. So it's not a direct replacement for RDBMS, and it's not a complete substitute for HDFS when doing a large batch MapReduce. So with HBase, table schema and column family must be predefined. Each table must have an element defined as primary key, and all access to the table must have primary key. The nice thing about HBase is that column family allows for many attributes to be grouped together and stored together, result in fast data lookup. Also, new columns can be added to families at any given time, and that makes schema more flexible. Advantages. HBase has a very flexible schema because column can be added to predefined column family on the fly only as needed. It's fast record lookups for large tables. It's strongly consistent reads and writes. It has automatic sharding feature. HBase tables are distributed on the cluster by regions. And regions are automatically split and redistributed as your data grows. It has automated region server failover. It supports HDFS out of the box as its distributed file system. So the installation is very straightforward. HBase supports an easy to use Java for programmatic access. It also supports massive parallelized processing by MapReduce. And also it supports Thrift and REST for non-data front end. So when to use HBase? To use if you need to store large quantity of sparse data and you need to add new columns frequently, and most of the columns are new in each row, and if you cannot live without the extra features that RDBMS provides. HBase provides a very comprehensive list of shell commands. You can use the commands to perform general tasks such as check for status of the servers, check for HBase version. Shell commands can be used to manage tables and manipulate the data. and also to perform the system administrative tasks such as starting the application, splitting the region. You can find the full list of the commands from the site listed here. Below are a few examples how to invoke shell commands to create table movie with column families, movie ID, title, rating, and runtime. Keep in mind that before you operate on the table, you must have to disable the table first. Let's talk about the proof of concept. My goal is to get familiar with Java Client API. So I took the SQLite database that contains small set of movie data and converted into the HBase tables. So for this purpose, I set up my local to run HBase in a standalone mode, which is strictly used for development. In order to scale, you must run HBase in the distributed mode, which is a bit more involved to set up. Next, I designed simple HBase schema, wrote Java program to load data, and then perform operation on those newly created tables. Here are the list of softwares that I need that need to be installed for my POC. I need HBase, Java, SQLite JDBC driver. This driver is needed for loading the data from SQLite relational database. I do my development using Eclipse IDE, and I run my code in the virtual machines that has the CentOS 64-bit operating system. It's worth to mention that you have to configure the HBase XML file correctly in order for Java client to connect to the master node. Also, you need to specify the directories to write your site-specific configuration. You have to specify HBase, Zookeeper quorum, and Zookeeper client port. Zookeeper is the high-performance coordinator service for distributed application which HBase relies on data modeling. Please note that an application built against an RDBMS cannot be ported to HBase by simply changing the JDBC driver. You have to completely redesign your schema. About the movie database, the table schema was designed for relational database. There are 5 tables involved: movie, Oscar, person, actor, and director. The actor and director are conjunction tables used to capture many-to-many relationships between movie and person tables. Those conjunction tables are needed in order to avoid the data redundancy. And these tables are designed with predefined column types, length, and with some constraints. For HBase, I only needed 3 tables. Many-to-many relationships can be modeled right within the movie and person tables without running into issue with data redundancy, because we don't have to create column for those rows that contain new values. Here is the Java code snippet used to establish session with the HBase master. We need the configuration in HBase admin objects. You can set a lot of property on the client side. Here I set up client to connect to the server localhost. I set up the session timeout. Create a table movie. We need each table descriptor objects, and then we create the column family and add it to the table, and then invoke the create table method to create a table. Here is another example. This code is used to insert the movie ID and movie title to the movie table. We use the put command. Keep in mind that you have to serialize the data. That is the byte objects that we can use to accomplish that. Below is a sample of scan column family of table movie. We need to scan objects, and then we define which columns that we want to scan, and then issue the get scanner method. The good news is there is lots of information available online regarding HBase, so that makes the learning curve much faster. Listed here are the very useful sites. I get most of information from here for my projects. Conclusion: HBase cannot solve all the data issues. HBase should be considered if you have a lot of data to process and you don't need RDBMS features such as optimizer, joins, cross-record transaction. It is a good candidate if there is need to add columns frequently and most of the columns are new in each row. My next step is to configure HBase to run in the distributed mode and integrated HBase with MapReduce. Thank you so much for your time.